continue from previous last video where we check the minimum steel requirement, and based on that we modify our steel calculations, the minimum steel the tensile steel calculations. Now there is one more check that we need to pass on, that is called crack control for shrinkage and temperature effect in clause 9.5.3. Now this requirement also need to be satisfied, making sure that the calculated and the one that we passed on, which is we calculated 326 and 433, making sure that all these three values are satisfy this 9.5.3 crack control. Okay, what is that one? Reinforcement in the primary directions. We are working in the primary direction along the longer spans, as I suggested in the previous videos. This is the primary directions. We are providing the reinforcement along this primary direction. So we are providing primary reinforcement along the shorter spans and along the x directions. Now primary direction, so in that case you need to go to clause 9.5.3.2, that is say the reinforcement in the primary directions. If you read about that in the B, says that 75% of area, and then you need to come to this clause here 9.5.33 and 9.5.34. so basically we need to take the 75% of these. I think there are different exposure classifications. Fully enclosed within the building, brief exposure varied during the construction. I think it does not say anything in our example, so but we can make an assumption that for a slab fully enclosed within the building for a brief period of so let's say the slab is located inside that construction, so it's not so in that case we are taking this A, and in that one let's do the moderate degree of control over the cracking. If you have different conditions, it's easy to adopt these values, different values, but let's take this moderate degree of control over the cracking required where crack are in consequence or hidden from view. So in that case you have this 75%. please take note this 75% of this value 3.5 minus these all numbers. All right, let me explain you this sigma cp. Now sigma cp is taken 0 because we have no pre. So if you are designing the pre-stressed concrete, then in that case you need to take into account this sigma cp, and the definition of sigma cp is given on page number 31, where you can see average intensity of effective pre-stress in the concrete. We don't have pre-stress, so we are not taking into account that pre-stress value. Now in this case we just have this one 0, so we multiply by 0. Now B is a 1000 millimeters. I think in the last videos where we are assuming this 1 meter wide strip, so it's the B is 1000. Depth D, in the previous video where we have this depth D, the overall depth D is 150 millimeters times 10 to the power 3. Simplify this. If you cancel this thousands and 10 to the power 3, that will just gone. So 0.73.5 take away 0 is 3.5 times 150, or you can use these calculators. It's give me 393 millimeters square per meters. All right, let's check it out. That in the last final steps we have, in the previous video we work it out 3 different areas. Area here, area here, and area here, and we're making sure that this 393 is the minimum now that need to be satisfied. So over here at continuous supports, at continuous beam, you have 433. So 433 is greater than 393. So that is okay. We can take 433 millimeter per meter. That is enough for the crack control of shrinkage and temperature effect. Now let's check it here. 326. Okay, that is not adequate because 326 is less than 393. We need this AST value greater than 393, so we can't use 326. Let's adopt 393. So let's take 393 millimeter square. Again 326 here at this discontinuous edge is not adequate, so 326 will not going to work. Let's take 393 millimeter square here. So now final reinforcement that require a primary reinforcement at the mid part at discontinuous and continuous stage is given here. Now those reinforcement has passed 2 checks. One check, crack control for shrinkage and temperature effect, and the second check is the minimum steel requirement. So this area calculation of tensile reinforcement calculation should pass these 2 checks. So these are perfect now. So we are finalizing this reinforcement area. Now the next steps, we need to find the spacing. How do we going to find the spacing? So I'm going to use this one table. Otherwise you can just simply calculate by hand as well. Probably in the next video I can show you how to calculate by hand. But spacing at the mid spans, I'm using these tables. Yeah, the area is 393 here at mid span, 393 millimeters square. So and we are using N12 bars. I think we have assumed that N12 bars. We assume N12 bars, as you can see, assume N12 bars at the start. So we have that N12 bars. For N12 bars, so we are working on these columns here, N12 bars. Please note these values are millimeter square per meters, and now we are targeting 393 millimeter square. So come back here and check it out close to 390. Okay, here I found it. 390 millimeter square is adequate, so I can take 390 millimeter square. For that, spacing is 280 center to center distance, so I can take 280 N12 bar that has the area of 390 millimeter square per meter, that is at mid span. At this continuous edge has the same area, so I would say that exactly the same reinforcement. I can provide 280 millimeter center to center distance and 390. Now at continuous edge has a different story. Different story means you have different area, 433 millimeter square per meter. So for that 433 millimeter square per meter, we can again use N12 and 433. We are here between, we cannot find 430. We have 422 and we have 460. So 430 falls between these two values, 430, 440 and 460. So we can take the average. 420 plus 460 divided by 2 is give me 440 millimeter square. So that is close here. That is because you are in the middle, millimeter square per meters. And similarly, we can take the average. 260 plus 260 plus 240 divided by 2 is give me 250 millimeters. So I can say that for the area of 440 millimeters square per meters, we need the center to center distance 250 millimeters. Or you can do the interpolations here. Okay, we have shown the interpolation, so you can use the interpolation as well. But at the continuous edge, we are using 250 center distance, and that satisfies this 433, which is 440 millimeters square. Now please note here we need to use those rounding numbers. We can't just specify 210, 208, 205. The builders will not going to go and measure those millimeters. They need just very rounding 20 millimeters increment of this distance. Now this is the bottom Rio. Let's say if I want to provide this bottom reinforcement at the mid spans, if you remember that, okay, here you go. If you know this one, M positive M star, so to satisfy this requirement, we have this reinforcement here. So this bottom reinforcement mid span, we have 280 centers and 12. So let's say N12, all bottom reinforcements are provided here, and this is bottom reinforcement at the mid spans. They are located here. N12 bars 280. If I'm looking from these sides, I would see these bars. If I'm looking from this side, I would see these points that are located here, and that is the bottom Rio at the mid span. Similarly, I can use the let's say at these supports, which is discontinuous supports, and I need to provide the standard cock. I think in the development length video we have discussed this cock. So we have these supports here, which is, let's say, these values here. I think these are not correct, because at this edge over here, at this continuous edge, we just have this tree. So I would have a correction here, that we don't need to provide this all the bars. We just need to have at this continuous edge, which is at this supports. Let's say we have these 3 bars. Let's say we have these 3 bars here. Okay, we don't need to provide this. Please make a correction here. So these values was, I think, 280, that is 280 millimeters. So here we have a discontinuous edge, we have 280 millimeters center to center distance. Now in here where you have this continuous edge, I think we don't need to provide those here. I think in the following video I will have a nice figures. But then you have this continuous edge where you can provide this reinforcement here, that is shown in the blue color. So if you are looking from this side, you have this top reinforcement at the supports. They are located here, that is continuous edge, and you have this continuous edge. You have provided that that reinforcement over here. So that is the top Rio at the continuous edge and this continuous edge that are shown on this drawing. In the following videos we will continue solving this example. Thank you.